Hi and welcome to another video tutorial. In this video tutorial what I'm going to be doing is showing you how to time the execution of small bits of Python code. And the way I'm going to do this is through an example of timing two sorting algorithms. Now we're going to need to use a library to do this, and the library we're going to use is called Timeit. So first of all what we have to do is import Timeit. So that's our first thing we do in our Python file. So timing your Python programs can be very useful when you come up with multiple ways to solve a programming problem and you want to see which takes less time to run. So the example I'm going to go through is comparing the time taken for the computer to sort a list using insertion sort and tim sort. And tim sort is the inbuilt sorting algorithm used by Python's sort method, which you can call on an object like a list. And insertion sort, I've implemented the pseudocode algorithm from the Wikipedia page on insertion sort, just here. So we need two functions that we're going to test, and these functions I've just called test tim sort and test insertion sort. So all these functions do is they define a list, and then this one calls insertion sort on the list, so it will do the insertion sort on the list, and this one calls the sort method, so we're calling the sort method, then it will do a tim sort on the list. So first of all then, let's make sure that these sorting algorithms both work and both produce the same result and sort the list correctly. Okay, so in the main part of our program we're just calling the test insertion sort method and then the test tim sort method, and in each of the methods I've printed out the value of my list once the sort has been completed. So we run this code now. We should see that both of the lists are now sorted correctly and using each of the algorithms. So now let's move on to actually using the Timeit library to time the execution of these sorting algorithms. Okay, so this is the line of code here that we need to test the time it takes to do the insertion sort. And what this does is it prints insertion sort, so we're just printing that so that we know which time is for which algorithm, and then it calls this Timeit function in the Timeit library, and this function takes two parameters. It can take more than two parameters, but we're just going to pass in two parameters in this example. And the first parameter it takes is the code that we want to execute as a string. And this second parameter, globals equals globals, and then to open bracket, close bracket. What that does is it specifies that we want to execute the test insertion sort in the current global namespace. This avoids us having to specify which function here we want to run in an import. Okay, so then that function timeit.timeit will return a floating point number, which is the amount of time it took, and it will be converted to a string and then printed out. The time that it returns is the time it takes to execute a specific the function a specific number of times, and the default number of times is 1 million. And one of the reasons it's 1 million is having the number of times set to 1 million reduces the effect of other processes running on your computer on the results. So this time that we'll get from this timeit.timeit is the amount of time it takes to execute test insertion sort 1 million times, and then we can directly compare that to the number of times it will take to execute test tim sort 1 million times. You can pass in an additional parameter here. If you can pass in number equals something, and that will change the number of times the code is executed, but the default is 1 million, and that's usually fine. Okay, so this is done now. We've written 2 print statements that should print insertion sort and then the time it took to execute this test insertion sort 1 million times, and we've written another print statement that prints tim sort and then the time it took to execute this test tim sort 1 million times. So if we run this now, we should get 2 times, and that will allow us to compare the time efficiency of each of the methods of sorting. Before we run this though, we are going to want to get rid of these print statements because we don't want to be printing the result of the sorting 2 million times. Okay, so if we run this now, let's see what times we get. So it'll take a second to execute, and there we go. So it took a little while to execute there, not very long, but a little while because we are doing these sorting algorithms 1 million times each. And you can see it took my computer almost 1.3 seconds to do the insertion sort 1 million times, but it took my computer around 0.25 seconds to do the tim sort 1 million times. So you can see that the tim sort is much more efficient than the simple insertion sort. Okay, so I hope you found this video tutorial useful on how you can time the execution of programs and see which one is which solution to a problem is most efficient in terms of the time it takes. Thanks for watching.